Hello everyone, my name is Jessica Blyler and this is my screencast on my STEM perspective. I'm 24 years old and currently teach 3rd grade at Melrose Elementary in the Harrisburg School District. I had the opportunity this year to have my class be part of a STEM mentoring program through C Research. This program allows my students to explore STEM with the assistance of high school mentors. This grant has allowed us to research and discover many things through hands-on projects. I also teach STEM at a summer camp in the city. I have always been interested in math and science, so pursuing a STEM endorsement seemed like a no-brainer. I love investigating, observing, and exploring topics. Outside of school, I enjoy staying active. I coach swimming after school in Carlisle. I also coach Girls on the Run and am a running buddy. And I play on a kickball team. My boyfriend and I have an adorable mini golden doodle named Chance that keeps us very busy. My favorite candy bar is a Reese's Peanut Butter Cup, if that counts as a candy bar. How do students learn science? After reading these modules, it allowed me to think more about this question. Students learn through observation, imagination, and reasoning, as Donovan and Bradsford describe it on page 405. Experiments and the scientific method are often too structured and involve written down step-by-step instructions to really allow students the opportunity to observe, imagine, and reason about science. Donovan and Bradsford also explain learning as allowing students to change their preconceptions with authentic inquiry that allows them to challenge their experiences. Metacognition can be simply defined as thinking about thinking. Students need to have opportunities to reflect, explain, and monitor their own understanding and ideas. Educators and teachers are challenged with many barriers in teaching science. First, teachers must engage any preconception students have in order for them to understand science. Donovan and Bradsford explains that how people learn emphasizes that instruction that does not explicitly address a preconception will fail to refine or replace that idea. They use the example of the fish story to convey that initial understandings lead to false ideas in further understandings. This notion leads to the challenge of engaging prior understandings. I really like the one quote on page 4 in chapter 1 that reads, "New understandings are constructed on the foundation of existing understandings and experiences." A barrier that I see specific to the students in my classroom today is the lack of prior knowledge and the lack of experiences. It is difficult to build their understandings in 3rd grade when I must start at a younger level. The final barrier that I would like to point out is the challenge of perceived advantages of the scientific method. The step-by-step procedure is viewed as a strong science-engaging, inquiry-based activity. After these readings, I understand the problem with structured step-by-step instructions. The imagination, observation, and reasoning is taken away. We often give the students the challenge or question that needs to be investigated. Unfortunately, but thankfully, now that I will be able to correct them, after these readings, I have noticed that there are many strategies and experiments that I do not adhere to in the tenets in this module. I have my class do many experiments and use the scientific method to investigate. I usually give them a question and they must plan, investigate, and build a solution to. This does not allow them to observe or wonder about a phenomenon. My classroom does adhere to the importance of metacognition. I allow and challenge my students to critique their claims and reflect on their thinking. I ask questions and have taught them to question questions and to ask questions of themselves. They understand self-monitoring and take ownership of their learning. As Donovan and Bradsford state as principle number 3 on page 12, my students try to take the opportunity to learn and grow to become effective learners. And finally, my STEM perspective is a transdisciplinary program like Bybee shows in figure 8.9. Currently, this is my goal. This is where I want to get to in my teaching of STEM. I know there are a lot of things I need to improve on and teach differently in order to truly teach STEM as a transdisciplinary program. My current school views STEM as a separate science discipline that incorporate other disciplines, as figure 8.3 depicts. Our STEM lab is commonly called the science lab as well. The term is interchanged because most of the projects and investigations done in the lab are science-based. At the summer camp I teach at, STEM is interchanged with technology and engineering. This is similar to figure 8.7, combining 2 or 3 disciplines. Overall, my STEM perspective is one of questioning, observation, and inquiry. These key ideas connect to a learner, knowledge, assessment, and community center environment. Those are my resources. Thank you.